Alright, hi, I'm Alexander, and my project is the 3D printed robotic arm. So, I'm going to put this on. You can see over there, it's counter holding it. When I move like this, yeah. So, the original project only called for just the forearm and the hand, but I modified it, and also the glove would have been attached to the hand, but I modified it to have both wireless communication between the glove and the arm, and also to have this little rest for the arm. I did unfortunately, I did unfortunately run out of time to complete like a control circuit that could actually like allow me to move this with a Arduino or like anything really. So what I do is I plug it into a battery, and then it just turns the motor. It's like so. It has an elbow, which is like your normal human elbow. So it can rotate like this. It also has a rotation joint, something humans don't have, in upper arm. That allows it to turn around 360 degrees. And I have 3 batteries for it as well. So it looks relatively complex, but it's actually quite simple. On the glove here, it's like Rohit's project actually. I've been here the full 6 weeks, so I've had a lot more time to work on it. On the glove, there are the flex sensors, which are strips of electrically conductive material. When you bend them, the particles of conductive material inside the flex sensors get farther apart from each other, which allows them to conduct less electricity than they would if they weren't bent. The Arduino here sends them power, and then based on the amount of power that it gets back and the difference between those two, it reads those values and converts it to degrees. It then sends those values, those degrees, through this wireless communications chip here. I'm not sure if you can see it, but it's kind of small. It's called an RF24. Then it sends those values wirelessly to an Arduino that's actually inside the arm here. It receives those values and uses it to control servos, which are contained within the forearm here, like where they were on Rohit's project. Those servos pull fishing wire, which manipulate these fingers to either go up or down depending on how the servos are pulled. I had quite a few problems with building this arm. One of those problems being the fragility of 3D printed parts. When I was making this whole assembly, which is controlled by just a bunch of gears and motors, one of the gears actually snapped that I was using because I was pressing it in too hard, and then it snapped because various reasons. Yeah, so I had to super glue it back together and clamp it for about an entire day. But then I put it back in, and it works just fine now. Major lesson I learned: always plan ahead. Whenever I made like any modification, no matter how small, I basically had to redesign my whole circuit. So my circuit's really contained on this board here and another little board inside the arm. So my original problem was that this battery puts out 7.2 volts. However, the servos inside the arm can only take a maximum of 6 volts. When I tried to do it the first time, just plugging the battery straight in, fried one of the servos and I couldn't use it anymore, so I had to get another one. To solve that problem, I built a voltage regulator circuit, which basically, it steps down the voltage and releases the excess voltage as heat. And that's inside of here. That required a full redesign of my circuit, because basically everything I was doing was delivering power to the servos and controlling them, so that's about half my circuit. And then the wireless communications part actually required me to rip apart my entire circuit and then put it back together in 2 separate pieces. Although through all of these challenges, the instructors and the environment here at BlueStamp helped me overcome them, and I'm very grateful. It was a very fun 6 weeks for me. Thank you. Questions? Eric.
What is the significance of the name of your wireless module?
RF24, it's on radio frequency, and then it's actually 24, but I don't know why. It operates at 2.4 to 2.5 gigahertz, usually around the 2.4, so RF24, radio frequency 24. Anyone else? Yes?
So, what was most interesting about the project before you started it?
Before I started.
And then in retrospect, what did you find the most interesting?
Okay, so when I started, I just wanted I guess I wanted a challenge, sort of. I hadn't really done electrical engineering before, or mechanical engineering, so it was a pretty big challenge, but yeah, it just interested me, because as Rohit said before with the same project. It's just something you can control without it being attached to you. And I think the end result is actually quite interesting. It actually has a range, like if you stand over there and I stand over there, I can still control the arm. So it interested me, I guess. That's my answer. In retrospect, what most interested me was just like taking these little individual parts that seem like just useless or random together, like say, I don't know, just these flex sensors, like, I don't know, they bend and they resist electricity, like, that doesn't sound like much, but like, it can control this, and that's rather interesting to me. It's just taking all these disparate parts and putting them together. Yes?
Have you used it for picking up objects or anything?
I haven't really tested it a lot, I will say. That's probably what I should have been doing more. Due to the design's limitations, it's not the most maneuverable because it basically only has like a tendon and nothing else. Human arms are really complex, like really complex. I looked it up and I'm like, oh, I'm gonna build this, and then, no. So, basically it can like, yeah, so it can, really, all it can do is flex like that about, and it can go down, but it doesn't really have the maneuverability that human hands have, because it only has one spring. Also the thumb is weird. It retracts and goes out, and then, yeah. It's a limitation of the 3D parts.